I guess our intro didn't run, so I'm live and looking around and clicking stuff while everybody's watching. So welcome again, episode 47, testing and troubleshooting for security device deployment. So we're going to be talking about a lot of things that should be familiar if you've tuned in before, because a lot of the things that we do relative to smart buildings are tied into what's happening in the security world as well. And the timing is good for this episode. ISC West show is getting ready to happen, so good timing to chat a little bit about security deployment and what you might need to consider when it comes to testing in preparation for that type of deployment. So one other thing I wanted to point out, I'm going to go ahead and share my screen here. We have on our website, pardon me, a vertical spotlight. In one of the sections of the vertical spotlight, you will see some information about testing for assuring infrastructure readiness, which is essentially the same thing, for the security market. So if you're on the main website, aem-test.com, and you click the little hamburger button in the upper right-hand corner, you'll see a bunch of different links here, and you'll go down to the content library, and we'll click on the vertical spotlight. And in the vertical spotlight, we see things for education, security, healthcare, data center. So this will be updated as we add content. Pardon me. And I'm going to go ahead and click into the security vertical spotlight here. And we talk a little bit about this in this spotlight about assuring the infrastructure readiness, use of older cabling, PoE, exceeding cable distance limitations, DC resistance issues, TCL, EL, TCTL. So we'll talk a little bit about some of that. Today, we're really going to be using the Network Service Assistant, the NSA. So you won't be doing TCL and EL, TCTL with the NSA, but you would do it with the certification tester, our Test Pro Multifunction Certifier. But you can do things like DC resistance unbalance and all these other things. Pardon me. So we'll be talking about that as well. So I am going to pull up another couple of slides here to chat with you about. So let's talk a little bit about this smart buildings thing. And in case you haven't seen our smart buildings or assuring your infrastructure readiness for smart building technologies, some of these slides are from that presentation. So we're going to talk a little bit about the integration of traditional network cabling and security and device cabling and all that. So, back in the day, we had a traditional building. You would have separate cabling systems for your phone and data and various devices that we had in the building. A lot of those have now come together under the IT type cabling. A lot of things are running over IP. So cameras, IP cameras, things like that. Access controls and occupancy sensors, all these kind of things that are kind of engaged in the security market are running over our typical data cabling. And way back when, we had Cat 3, 10 meg, we had Cat 4 for a little while. If memory serves, that was 16 meg. And then that didn't last very long because Cat 5 came out and could go 100 meg, and it wasn't much more money. So Cat 4 kind of died. And then things have advanced beyond that. And as the cabling and the technologies that drive the network over the cabling have advanced, these topologies, these different things, the operational technologies and the information technologies are kind of coming together in the intelligent building, which includes the security devices, your security systems. And some of these still may run over a separate cabling system, and they may, in fact, come into the traditional Ethernet cabling and eventually move away from that. I'll talk about that in a second. So as you bring these together, the IT and the OT facilities people have to communicate, and they're essentially working with the same cabling infrastructure. It's all tied together on the network. So and you get power and data running on that same cabling. So there's more testing than we need to do. Back in the 90s, we were just testing the certification parameters on the cable. Yep, it looks good. We're going to run stuff over it. Yay, everybody's happy. Well, as time has progressed and we started running power, first we were running lower power over Ethernet. didn't require all 4 pairs, but now these higher power devices in effect are using all 4 pairs on the cable to carry that power from one end to the other. So we're going to have to think about that in terms of what do we do to make sure that that cable plant is ready to handle not just our network devices, but our security devices. How much PoE power do we need at the endpoint for any of these devices, these cameras, these controls, these motion sensors and things like that. So we've got to think about that with regard to the cabling, especially if we're going to reuse old cabling versus installing new cabling. We need to know if that older cabling is going to support what we're going to be running over it. So again, as I mentioned, I kind of got ahead of this slide. The times have changed. So can the noise affect the link on the overall network performance? That comes into that TCL and ELTCTL testing I talked about. Those parameters are an optional pass-fail limit in a certification test, and we run them in the same 6-second Cat6a auto test on our certification tester. So it doesn't add any time to that test, but it gives you an idea of how well the cable is constructed regarding being resistant to noise interference. And then will the link support multiple link speeds that you're going to require? Is it only going to be doing 1 gig? Is it going to be 2.5 or 5 or maybe even 10 gig? Now, most of your security devices are not going to be using those higher speeds, but if you're testing existing cabling, even though you have a security device that's going to be using less bandwidth, running at a lower speed, for instance, if you know that your cabling can support the higher speed data, what that means to you as the technician who's deploying it, or you're designing this system, you want to use this legacy cabling, for instance, is that you're going to have enough headroom on there. So if it's going to work for the faster speeds, it should work fine for your lower speeds, and you'd be fine. Now, one thing to point out about that when you're comparing 1 gig versus 2.5, 1 gig has tighter constraints than a 2.5. So because it passes 1 gig doesn't always mean it's going to run 2.5. So it's good to be able to have the flexibility to run these different tests, run speed tests at different speeds. And of course, we talked about PoE. So can that link support the power out at the endpoint? So you want to make sure that you can get power delivered. And with the proper PoE testing capability, you can connect to that link at the endpoint where your device is going to attach, and you can demand that power from the switch and find out, yes, I can get the proper amount of power to run my device at that endpoint, or no, I can't. And now I need to figure out why I'm not getting that power out at the endpoint, and you're going to need to troubleshoot. And we'll show you that test here in a moment. And again, this is real. This slide really talks more about certification. So, but it's applicable because the test we're going to show you with the network service assistant that I've got set up here, it's our Qualification Plus multifunction tester, are very similar to what these tests you see here are for certification, but they're just done from a single end. So that the traditional tests that we're used to seeing, the length, the delay, DC loop resistance, insertion loss, return loss, crosstalk, those kind of things. And you step it up a little bit with the plus parameters, and you're doing TCL and ELTCTL, you're doing DC resistance unbalance, for instance. So those are things, the DC resistance unbalance, we mentioned TCL and ELTCTL as being a measurement for the noise mitigation on the cable, if you will. And the DC resistance unbalance is really tailored more towards pre-qualifying your cable to make sure that it can support PoE, but it doesn't take the place of a PoE test. And you want to have troubleshooting capabilities, which we will here in the network service assistant. You'll see that TDR trace to a return loss or crosstalk issue or a shield problem. And then, of course, being able to test the gigabit or multi-gigabit links for signal to noise ratio to make sure that you don't, in fact, have too much noise on there, and that you can get that speed at the endpoint. We talked a little bit about resistance. So it's specified in the standards, your loop resistance can't exceed 25 ohms. Resistance unbalance in the pair needs to be less than 200 ohms or less than 3%. And then pair-to-pair is less than 200 ohms or less than 7%. And that's just comparing, that pair-to-pair compares the DC resistance value of one pair to all other pairs. So it looks at every possible combination. And again, I mentioned earlier, DC resistance unbalance test is not a PoE test. If you hear somebody call it a PoE test, it's not. It's a resistance measurement, and it lets you know that that cabling should support PoE, but it is not in fact a PoE test. And if, again, we mentioned using older cable, one thing to consider if you're using older cabling is to look at things like the cable type and what it can handle as far as these higher speeds. So, if you look at this, Cat 5e is okay at 2.5 up to 55 meters. At 5 gig, it's okay, but it's not as good. And of course, you're not going to run 10 gig over it at 55 meters at all. And beyond that distance, none of those speeds will work. And then as you progress higher up to Cat 6 and then on to Cat 6A, you're assured of that performance, especially with the Cat 6A. You pretty much can run all of these on Cat 6A without a problem. And Cat 6A would be, again, if money's no object and you're designing something, Cat 6A would be the better choice, especially if you're going to be running PoE as well, because it's typically going to be a heavier gauge, which will work better for PoE because it has a lower resistance. So let's jump in and talk about some of the tests you might run. Now, I mentioned coax. I've got a saved coax test that we'll show you here in a moment. I'm going to run some twisted pair tests. I'm going to run some network tests, some multi-gig tests, so we can kind of look at it. We'll do some PoE testing. So, we'll start with the physical cable test. We want to test that cable to make sure that it's okay. So I've got my network service assistant right here, and my display is blank here because I've transferred the display over to my computer to make this demonstration easier to see. I've got my adapter plugged in the top. I have a cord plugged into the top of my NSA, and it goes over here to the end of this cord. And then in this patch panel, I've got some loops of cable behind here. Some are good, some are not so good, that we'll run some tests on and see what we get. Now, NSA, instead of a physical remote like our multifunction cable certifier, uses a remote terminator like this. For coax, it's a remote coax terminator, essentially a little cube with a coax connector on it. This remote terminator, it's not just a dumb terminator. It actually allows us to loop back some of the testing that we're doing in the RF parameters so that we can get all that information back to the main end. So I'm going to I'm going to connect to this first pair of ports here on the patch panel, and I'll show you this. We get a live wire map as soon as we connect. So I'm going to disconnect. I'll plug this cord back in. You'll see we get a live wire map just like we do with our Test Pro multifunction certifier. The reason the live wire map is going to be important for you, whether you're doing security applications or network or anything else, live wire map tells you right away that you've got an issue. And instead of having to run an auto test and then find out, oh, my wire map's bad, we give you wire map up front so that you can troubleshoot. So this I can see I've got an open and a short. So what I'm going to do is I'm going to click right in the middle of where the wire map is, and this will do a cable diagnostic. This works the same way on my Test Pro multifunction certifier, and on the Test Pro you can do it from either end. So the other end is going to look identical. They both have displays. You can pull this information up from either end, and it'll show you the distance to that fault relative to whether you're at the main or the remote. Of course, with NSA, we're only single-ended, so this is distance from my NSA unit itself. So 48 feet roughly to the open, about 46 to the short. My experience tells me that those are pretty much going to be the same event. And because my cord here comes from my NSA right here and plugs in, I know that the issue is going to be at this other port. So the other end of the cable where that remote terminator is. And I can flip these and we can actually see, if I flip where these are in the panel and run the diagnostic again, you can see that it should now show us that it's closer to my handset. It'll show me the length of the cord roughly, and it'll be just past that cord. So roughly 8.5 feet is where my issue is. So I know it's at my near end. So that's where live wire map comes into play. Now, we've got another cable here. I'm going to hook up. Wire map looks good. I'm going to run an auto test. Now note, this auto test will take about about 8-10 seconds maybe. On our multifunction certifier, it's a 6-second audit test for Cat 6A. It takes a little longer when you're running that test with the network service assistant because the main unit, this handset is doing all the work. There's not another tester at the far end that's doing part of the testing. So we can see this failed. I've got some issues here with crosstalk and return loss. I'm going to go to my details tab and I'm going to scroll down. Now, earlier I mentioned having tools like a TDR function built in to find your problems. So return loss locator right here. I click that. I can see I've got return loss right here at my near end. I've got a pretty big spike right behind this patch cord. So return loss is a bit of an issue. I'm going to go look at my crosstalk locator. Crosstalk, I've got some crosstalk at my near end, but I've also got a spike in the middle, and I've got a really big spike of crosstalk at the far end. Now, in all honesty, I have to tell you, this cable, it's not a Cat 6A. It's a 5E I put behind here, so we're going to have some crosstalk along it relative to what we would see for a Cat 6A. But also, I did an intentionally poor job, worse than I normally do when I'm trying to do a good job, of terminating. And on that remote end, I untwisted the pairs about 2 inches. So that's why we're seeing that crosstalk here. So this type of TDR functionality will help you pinpoint where problems are. The spike you see in the middle, that is a part in the cable that was kinked. So right there was a kink, and we can see distance to it. It's right at about 41 feet. So these TDR functionalities enable you to troubleshoot that. We could save that test if we wanted to as a part of a punch list, but I'm not going to do that. I'm just going to go on to the next cable, and we'll run a good test and save it. And then we're going to jump over to the multi-gig PoE and networking to show you some of those functionalities. Again, we want to make sure that we're not just being able to test that physical cable, but because things are all tied together over that network infrastructure, we want to be able to do other things. So here we go. We got a pass. I can look at my details. I can look at network compliance. I see, yep, I'm good up to 10 gig because it's a Cat 6A. I just saved that test, and you can see I've already saved a few tests in here. So that is the physical cable test part. Also in here, there's a toolbox. You've got a tone generator that will work with any RF probe. You've got learn MVP and length tests, so you can learn the MVP value of a cable. You can learn the length if you already know the MVP. So all that is kind of built in there for you as well to help you with that troubleshooting. So I'm going to hit my home button, and I am going to click on my my PoE button here, and that's going to allow me to switch to PoE testing mode. So let's say I have an issue with a PoE link. I'm going to go ahead and I am going to hook up. I'm going to run this little cable from my PoE injector over to my panel. So I'm connected there. I'm connected here. And once we get power over Ethernet up, oh, it helps to be in the right port. Let's just use this one. A little closer. I had a short cable here, so took a chance it didn't reach. So let's plug into another link here. So this link comes up. It's showing me I've got 55.76 volts. So I've got 55 volts. I've got PoE on all 4 pairs. PSE type 4, PD class is 8. So this is pretty good, and I'm set for 90 watt. You can select up here which one you want, whether you're doing 90 watt, 30 watt, 15, or if you're doing this UPoE 60 watt, you choose the one that you're testing for. I'm going to do a PoE load test, and what's happening now is my network service assistant is demanding the load from the switch. You'll use this test should you get a call out and say, oh, I've got a PoE device that's not working, it's not powering up properly, or I'm having intermittent issues with it that I think might be related to power. And I see here I'm getting 69.33 watts at this endpoint out here. Maybe that's, in my case, that's fine for what I'm running, but maybe it's not. I can actually bump this a little to see if I can eke a little bit more juice out of this. So if I hit the plus button on the load, I can get 81 watts over this link without a problem. So the number we saw in the beginning, that 71.3, you may see that on some basic PoE testers. You may see that allocated power. It may show you, yep, 71.3 watts. That number is good to know, but it's only what the switch should be able to provide you at that endpoint. It's not a real power load test. So it's really just what the switch is advertising it can give you at the end of a perfectly good working cable. So beyond, and what you would do with that test, you'll troubleshoot. Yeah, my PoE doesn't look good. Now I'll go back to the closet. I'm going to plug into the switch, see if the switch port is giving me the power at the port. If it's not giving you the power at the port, then you need to look at things like provisioning of the port. Maybe it's a user provided their own PoE switch and they spent $100 on Amazon to get a 12-port 90-watt PoE switch. Anybody that knows anything about PoE switches knows that 12-port 90-watt switch for $100 is not going to give you 90 watts on every port. It's going to be 90 watts for the whole switch. Once you plug in a couple devices, you're not getting the power that you need. So those kind of things can be discovered using the PoE tool. The other thing you can look at is patch cords. People forget about this. If you use, we used to call them schlock patch cords back in the day, really poor quality patch cords that has poor resistance, that can impact your PoE as well. So you use that as a troubleshooting tool. This multi-gig test here, I'm going to go into the multi-gig test. Now I happen to know this link I've got doesn't work well on 10 gig. So what I'm going to do is I'm going to go into my project and I'm going to uncheck the 10 gig. But if we wanted to test 10 gig, we'd leave it checked. And I'm leaving the default IEEE values of 0 in here. Once SNR gets below 0, then you are below the threshold that is at the bottom end. But you could set these for 3 dB or 6 dB, whatever you wanted to set. I'm leaving it at 0 for now. And we're going to go ahead and run that auto test. Now what this is going to do, it's going to run for all the speeds I've selected. It's going to run a connection test at 100 meg and 1 gig. And then at the multi-gig speeds, 2.5 and 5 gig, it's going to run that connection test, and it's going to do a signal to noise ratio test. So what we're doing for signal to noise ratio, SNR, is we know the signal strength of the traffic we're putting on that link, and we're measuring the noise relative to the strength of our signal, and that's the signal to noise ratio. The higher the number, the better, because it means your signal is stronger than the noise itself. If you need to run SNR testing for 1 gig and 100 meg, you can do that through the side Ethernet port built into every Network Service Assistant and Test Pro handset. So that can be achieved there. But the PoE and multi-gig, you have to do through that top of that adapter there. So here we see our SNR looks good for 5 gig and 2.5. I can click the view button and see it by pair if I needed to. So I'm able to determine if I did have a problem with it, I can see which pair is giving me the issue. My connection at 100 meg and 1 gig was good. I see I've got my PoE here, 69 watts. I'm fine. I'm going to go ahead and save this result. So now I save that, and now I've got a record of that link. So this is good too, because you can do a physical cable test of a link, and then when the network equipment is hooked up, you can do this other test as a supplemental test to give you proof that yes, it's working. When we left the facility, we were getting the amount of power we needed at the endpoint. The SNR values look good on the link. Everything is fine. So you've got that, whether you're going to sell that to your customer as a, an add-on, an additional revenue stream for you, but an additional service for your customer to show them that yes, not only is the physical cable test look good, but the SNR values look good. You got power at the endpoint. So it's just more information for that end customer. But also, just like all test reports, it's protection for the installer, because you left the facility, everything was working. You come back, there's a problem, then you can start doing some investigating, and maybe something has happened to the cable in the meantime. Beyond this type of testing, we can go into our network test function. And what I'm going to do here is I'm going to go ahead and connect to another switch here. And I'm still using this same adapter. The same adapter I did the physical cable test with, the same one I'm doing the network test, the multi-gig test. All this is through the same adapter. Coax adapters are available. Fiber adapters are available as well for both the Test Pro and this Network Service Assistant. You can do loopback fiber testing. So I'll go into network tests. When we go into the network, we're going to be able to do some discovery. We're going to start discovering devices, and we can look at the IP and MAC addresses of these devices that are on the network. We can turn on host name, and if any of these had advertised a name, in about 1 second per address, it's going to show us the host names that are advertised. Click this, and these can also be done with Pro. I can see information about the network. I can ask my IP server. I see that I'm a full duplex connection. I can click on the switch detail button and running LLDP. So we want to do a switch detail discovery here. So in just a couple seconds here, I've got the information on my switch. It's Whopper Cheyenne Mountain is the system name. It's a Meraki Go 8-port switch. I'm on port 5. I'm on VLAN 1. And I can handle everything from 10 base T up to gigabit Ethernet here. And my IPv4 address, my MAC address, all that is in there. So you get all that detail. Other things that you get in the toolbox, you get things like ping and traceroute. That same switch detail, VLAN discovery if you have access to a trunk port on the router or the switch, and then traffic generator. You can do traffic generation with a certification system. You can also do a traffic monitor on the remote end, and TCP connect. So everybody knows how to do ping, and yeah, you can do ping and traceroute on a laptop, but wouldn't it be nice to have it in your handheld tester so you don't have to pull out your laptop to do a ping or a traceroute? You know, if you're getting a slow ping, you can do a traceroute and figure out where's the bottleneck. Is it in my local network? Is it beyond my capability out somewhere in the cloud somewhere? Maybe I can't, I can't do anything about that, but I can do things about problems on my own network if that's where the bottleneck is. And of course, the TCP connect, you're able to look at the particular TCP port. So some of your services might use a particular port. You can make sure you can connect, and you can do a response test to make sure that you don't have any latency. And then you can also run an auto test that gives you a bunch of these network tests in the auto test. And then there's also Wi-Fi capability with the addition of a little USB Wi-Fi adapter. You can also add network test and discovery on Wi-Fi. You won't be able to do switch detail or do the VLAN lookup, but you can do the ping and the traceroute and the IP address discovery. You can look at signal strength. See SSIDs and their associated signal strength. So a lot of functionality built in there. And all this can be brought into test reports as well. So if we go into our PC software, and we have a project here, we imported all these into the project in our Test Data Pro PC software, and we're able to go in and generate reports. And we can see a report here. This is our Certi-Lite channel. So again, this is the Certi-Lite test. I mentioned it's single-ended, but it looks a lot like a certification test because we're running these same test parameters. We're just doing it from a single end. And then you've got reports like this one, the network test. So I did that network test. I can see my ping test, my device information. I can see the number of devices I connected. I can see the switch detail, so I know all about my switch. And then I can go here. I've got a coax, pardon me, a coax test. So we can see a coax test that we ran. We get our return loss and insertion loss and length on the coax test. Then we've got here we've got a fiber test. This is a loopback fiber test that I ran on about 100 feet of fiber or so, and it gives us all this information. Also notice right here I see 89 volt, 0.89 volts. So in this case I was actually measuring voltage. It was low voltage, but you can do voltage measurement with the fiber adapters on a hybrid powered fiber. If you're using our certifier, in addition to voltage, you can also measure the resistance of that pair of copper after you install it to make sure that it's still got integrity. So the test reports, the one thing about test reports, as I mentioned earlier, it's good for the customers. They get the warm and fuzzy. Your end user knows that they've got a good cabling system installed. They've got the documentation. For you as an installer or integrator, it's protecting you. It gives you that documentation that you did your job right. And if anything ever comes up and there's a problem, you come back and run a new test, you can actually see if there's changes in the cable, and you can use the TDR tracing capability to pinpoint where that is and say, yeah, maybe this isn't so good. Somebody cut it and spliced it, put a wire nut on a piece of Cat5e. It's not a joke. We've actually seen that in the field. So I'm going to stop sharing my screen now and go back to camera here. And we're right about at the bottom of the hour. I don't see any questions. I see Chuck said hello. Hey, Chuck Bowser, good to see you. Check out Chuck's Let's Talk Cabling. Don't miss it. He's on every Thursday night. So that's a good one to catch with him. So a lot of good information. Chuck gives a lot back to the IT community, the ICT community. So he's very good at helping to educate others in our industry. So make sure you check him out. And he's a lot of fun to watch, not just boring diatribe of information coming through. He's very entertaining as well. So make sure you check him out. So a couple little housekeeping things here at the end as we wrap up. Just to let you guys know, DHS Tools is going to be representing Smart Solutions for Smart Buildings, which is our test equipment, at Landline Tech Forum in Berlin with our very own Alf Sutherland. We're also going to be headed to that ISC West show that I mentioned in Las Vegas. So stop by Gray Bar's booth number 6058. And our very own Jim Florio is going to be there giving live demos at that booth. So again, one last thing, don't forget, we do have a promotion running right now for the Test Pro Multifunction Cable Certifier. We're doing a buy one, get one 50% off. This is a killer deal. So if you're in the market for a cable certification system, this is the way to go, not just because of the special that we're doing, the buy one, get one, but there really is no other tester, no other certifier out there like this. It is a true multifunction cable certifier. So you can do more than just certify the cable. All the things that I showed you today, the PoE testing, the multi-gig testing, the network discovery, you do all that in the same platform as your certifier. So take advantage of that promotion. If you're in the market, give us a shout, reach out to us. We've got reps, all over the place. We've got distribution partners all over the place, all over the globe, really. So if you're interested in that, please reach out. Now that promo is running in the U.S. only. So to our global partners, that is a U.S. promotion. So, please reach out to us if you're interested in a demo. So, again, my name's Steve Kells. Thanks for joining us, and we'll see you in a couple weeks in the next episode.